So I'm recording right now, and today is day 3. And I wanted to go over what we need to discuss for exam 2. On yesterday's video, we finished everything that we needed to do for exam 1. For exam 2, you should be focusing on chapter 1, section 1.3. And that was the question that we talked about radicals. And what specifically about radicals? We were specifying Pythagoras theorem, whereby that's a squared plus b squared is equal to c squared. Then, and I'm going in sequence here. The exam doesn't necessarily go in sequence for exam 1 or 2. But I'm going here in sequence regarding chapters and this is all for exam 2. For chapter 2, you're going to focus on 2.1. And some of these topics we're going to go over today. And did I put the page number? I didn't put the page number. This is page 45. 2.1, that's going to be page 102. And this has to do with finding x and y intercepts. And section 2.2, this is pages 112 and 122. This has to do with linear equations. And we did linear equation yesterday. For x, finding the x value. And page 122, that's the linear equation for when you're using 2 points. We did that yesterday. All right. Two 2.3. This has to do with page 137, and then this is the rectangle. We're going to go over this today. Just going to put this in red. All right. Section 2.5. This is page 155 in the book. This has to do with quadratic formula. We'll go over this today. So again, I'll put this in red because this is new. Quadratic formula, page 155. Section 2.7, this is page 183, linear inequalities. We'll go over this today. And then that brings us to chapter 3. That is functions. That's section 3.1, pages 201. And that is all of page 201. And section 3.2, this is page 227, and this has to do with domain and range. So this is exam 2. When is exam 2? You guys remember?
Thursday.
Thursday.
Ain't that Friday?
I think it's Friday. Yeah. Let me check. Because I know Wednesday is tomorrow Wednesday is exam 1. Right? So tomorrow Wednesday. So on Wednesday, August 5th at 6 p.m. room 1CO3 is the exam. and you have 80 minutes.
What time is it?
6 p.m. So you have to be there on time because the exam starts on time, starts at 6, and it finishes 80 minutes later. It's 10 questions, and you have 8 minutes per question. That's equal to 80 minutes. So if we start at 6, it's going to end at 7:20. So if you get there at 6:30, then you only have 50 minutes. So you don't want to do that. You want to make sure you leave your house early, you address your affairs correctly, because that is the time of the class, and you want to make sure you account for trains or buses, all of that good stuff. And then on Friday, right? So we have class online on Thursday, right? So let me write that here. So on Thursday, so this is in person. Tomorrow is in person. I don't want to hear that there's a misunderstanding that you thought it was online, the exam. No. Room 1C03 in the building. Make sure you get there on time. On Thursday, we have class via Zoom. And then Friday, which is August 7th, 2026 at 6 p.m., same room, 1C03. Again, you're going to have another 10 questions. And again, each question is 8 minutes. That doesn't mean that all questions are 8 minutes, but on average, the questions are 8 minutes. So that means maybe one question is 10 minutes, and the other one is 4 minutes, and the other one is 5 minutes. But when you average everything out and you add it up, it's 8 minutes. All right, 10 questions, 8 minutes. It starts at 6 p.m. and it ends at 7:20. And that's Friday. This is exam what on Friday? Exam 2. On Wednesday, exam 1. Now, what happens if you miss exam 1? Who wants to answer that for me? Anybody? Does everybody know?
Fail.
That's it. You get dropped from the course. So please don't miss the exam. All right. Try to get there early.
I have a question.
Go ahead.
What if you fail the exam?
Well, you still have time to redeem yourself in exam 2 and 3 because it's the average between all 3 exams. What should you be striving for on exam 1? What? I didn't hear you. What'd you say? What should
80,
everybody be
80.
striving to get on the exam 1? Nobody knows? You should be striving to get the highest possible grade. But the lowest grade that you should be getting is a 70 on the first exam. Because let's say you get less than a 70. What happens on the second exam? Let's say you get a 50 on the first exam. What should you be getting on the second exam now as a minimum? What's 70 minus 50? Nobody knows what 70 minus 50 is?
20.
20. So that 20 points needs to be added to what? To the second exam, right? So now instead of getting a 70 on the second exam, what do you need to get on the second exam?
90.
90.
Supposed to get a 90. Because now if you add 50 and 90 and you divide that by 2, what's the average? 140, right? 50 and 90 is equal to 140 and divided by 2 is 70, right? So this is why I tell everyone you want to do as good as possible on exam 1, because you see the topics on exam 2, are they easier than exam 1? Or are they getting a little bit more complicated?
Bit more complicated.
They're getting more complicated. So it's a numbers game, right? So don't despair if you fail exam 1. The lowest grade I got on exam 1 on my previous class was a 72. So if you guys are following the videos and you're practicing the problems, you're going to be good. And this is why I give you this. I give you this information here because this is what you need to cover for exam 2, right? You need to look at chapter 1, section 1.3, chapter 2, section 2.1, 2.2, 2.3, 2.5, 2.7. We're going to be going over all of these. Does that mean we're going to be doing all the pages in the chapters? No. Look, I'm very specific. Look at this. And I'm even telling you the page numbers. You know, look at that. That's pretty cool. So in reality, what do you need to concentrate on? You need to concentrate on how many pages? 1 page, 2 pages, 3 pages, 4 pages, 5 pages, 6 pages, 7 pages, 8 pages, 9 pages. If you are able to do 9 pages and the examples in those pages, you're good. How many questions are in the exam? 10. So that means one of these pages has 2 problems. It's a numbers game. All right. So we're going to continue. And we're going to start with the topic that we need to do. So let's talk about inequalities. Let's talk about inequalities. So does anybody have an idea how would the questions on the test be presented to us? So some question, like for instance, exam 1, some questions you're going to have to select the answer, but that's maybe 1 or 2 questions, and the remaining questions you're going to have to work out the problems. What do you mean a word problem? So on exam 2, you have a word problem. On exam 1, you're going to have a question. So it's going to say solve this, and that's the question. A word problem is different because a word problem is you have to extract the information from the word problem itself, and that doesn't come until exam 2.
Thank you.
All right. Does that help? Yep.
Yes.
All right. Cool. All right. No problemo. All right. So let's continue. Trying to see the sequence here. We've done all of this. We've done all of this. We've done all of this. All right. Should I do that or should I do this? The last topic I left yesterday was the lines, correct? You guys remember the lines? So in the lines, that was the last topic. And now for inequalities, let's look at a problem for inequality. So now, where are inequalities here? What are we doing now? Where are the inequalities? Right here, right? So we're doing 2.7, right? So today, Tuesday, we're doing this section, right? 2.7, page 183, linear inequalities. So we're doing a 2.7 section, linear inequalities, right? Inequalities. So let's learn about these inequalities, right? If we draw a number line, and this is 0, right? It's in the middle. If I go to the left, it's a -1. If I go to the right, it's a +1. If I keep going, so this is 2, 3, dash, 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 what's going to happen? I'm going to end up with positive infinity, right? And these are all x values. Where do x values go if I draw something like this? Where would they go? Would they go on the vertical line or the horizontal line?
Horizontal.
Horizontal.
You got it. So it'd be negative x and x. So the 0 would be here, and the same number line that you saw that I just did would go here, right? So this would be 1, this would be -1, correct? If,
Yes.
thank you. If I say on this number line, x is greater than 1, where would I put my first x value on this number line? Where would I put my first x value on this number line? So this is my number line. Where would I put my first x value if x is greater than 1?
Two.
So I am going to put it right here at 1. And I'm going to go like this. Because does my x value include 1? Or does it say it has to be greater than 1? It says it's greater than. This says x is greater than 1. Right? Now, let's do the same problem. And now I'm going to say x is greater than or equal to 1. Where would I start? Anybody?
1.
I'm going to start at 1. But look at what's going to happen here. What is the difference between x is greater than 1 up here and x is greater than or equal to 1? What is the difference in the circle? What do you
1
see?
is filled in.
1 is filled in. 1 is included, right? So whenever you have an equal sign underneath the greater than or less than sign, that means that the value is included. Now, what happens when there's no equal sign? When there is no equal sign, no equal, right? This, do you guys agree this does not have an equal sign? It's not included. How many of you are sitting down right now? Anybody? Are you all standing up? How are you guys taking the class? Are you sitting down or standing up?
I'm sitting down.
Thank you, Jada.
You're welcome.
So if Jada's sitting down, is the chair that Jada is sitting on giving her a solution? Is it part of Jada? Is she sitting on it? The answer is yes, right? So we can say that the chair is equal to this equation, right? That x value is the chair, and she is sitting on it. And this is why it's solid, because the chair is part of her, and she's part of the chair, because She's sitting on it. She's resting on it. Now, I'm also sitting on my chair. So this chair that I'm sitting on is my solution to my problem because I am tired. So since I'm tired, I want to sit down, and it's part of the solution. If I stand up and now the chair is over here, does that mean the chair doesn't exist? Is it now invisible? It disappears out of existence?
No,
Or is the chair still there?
it's still there.
Right. Since the chair is still there, am I sitting on it? If I'm standing,
No,
I'm standing next to the chair. That means the chair exists, and that is why it's an open circle. But is it part of my solution? Is it solving the problem that I am tired and I want to sit on it? When I'm not sitting on the chair, it is an open circle. When I'm sitting on the chair, that means it's an equal sign. It's solving the problem. I can include the chair. In this case, the chair is 1. It could be a different value. The chair can have different values. Now, let's explain not only the circle, but let's explain the arrow. And let's also explain not only the arrow, let us also explain the direction. So, let's talk about the arrow. Is the arrow going to the left or to the right? Here.
To the right.
To the right. So that means that in this problem, all values of x that are greater than 1 are a solution. But 1 is not a solution, but 1 exists. It's the chair. But I'm not sitting on it, so it's not part of my solution. But everything else on that arrow, all the way to the right, and where does the right end? What does this mean? This is called infinity. And because it has a positive, then we call this positive infinity. Do you know where infinity ends or stops?
No.
No, you do not. It just keeps going and going and going. This is a continuous solution to the right. So, let's talk about this concept. So, if it's x is greater than 1, then when I'm drawing this number line, I'm going to have an open circle, and it's going to go all the way to the right, and it's not going to stop, so it's going to go all the way to positive infinity. For what values? For values of x. If I have an x that is greater than or equal to 1, and I still have the same number line, and it's at 0, and this is 1, then this is solid, and this is going to the right, all the way to positive infinity, right? For what values? Values of x. Now, there is something called interval notation. Interval notation says, if I draw a bracket, I have a left bracket and a right bracket. This means this is included. If I draw parentheses, then it is not included. This here, well, I don't want to write it like that because I'm going to confuse you. It is included. Included. It is included. Right? There is an equal sign. Parentheses means no equal sign. Okay? Now, How would I write this in interval notation? This part here. Well, the way I would write it is I start with a parentheses. Why am I starting with a parentheses? Because I have an open circle. Why do I have an open circle? Because I have a greater than sign. Does this greater than sign have an equal sign? Yes or no? Do you see a little bar underneath? No, there isn't. So because of that, I have to have a parentheses. And I'm going to write 1 because that's my starting point. Comma. This comma reads the following way. 2. The significance of the comma is 2. Do you know where this stops? To the right? Yes or no? The answer is no.
No.
This is going to go all the way to positive infinity. Because you don't know where it stops, you're going to put a parentheses. This is interval notation. Now, for the right, do I have an equal sign? The answer is yes. If I have an equal sign, then it is solid. If it's solid, then I have a bracket, not a parentheses, right? Because that's what I said, right? It needs to have an equal sign. If it doesn't have an equal sign, then it's going to be a parentheses. But it has an equal sign, so it's a bracket. What is the first value? Well, the first value is 1. Where is this going to, right? Comma, 2, right? That's what that means, comma, 2. Do I know where it stops? Do I know where this stops? No.
No. No.
Positive infinity. This is interval notation. Now, what happens if you have a line, let's say, and it says something like this. X is less than or equal to 3, but X is greater than no, I don't want to do that. Hold on. The X value is less than the X value is less than or equal to 3. Where would I put this? Where? Where would I put it?
3.
The 3,
3.
right? So I'm going to put a solid. And do you know why I'm putting a solid? Because there is an equal sign, right? Where is this pointing to? Is it pointing to the left or pointing to the right?
Left.
To the left. This is going to go to negative infinity. How would I write this in interval notation? How would I write it? Look at the definition. Equal sign, no equal sign. Does this have an equal sign at the bottom? It has an equal sign, right? So I'm going to write bracket, but there's a convention on how to write this. Since you're going to the left, you're going to say it is going to be bracket 3, right? That's the positive number. And it's going to go to, right? Where's it going? To negative infinity. Now, you could also write it this way, but it's a little bit confusing. Because here you're saying that it's coming from negative infinity, right? Right? You're going the other way, right? It's going to go all the way this way, and it stops there, right? This way, which means the same thing, right? Negative infinity all the way to, and it stops at where? Where does it stop? Full stop. Stops at 3. Right? So this is interval notation. So now that we understand the number line, and we have examples of it, let me give you an example. I don't want to do that. I already did it. All right. -1, -2, -3, 1, 2, 3. If this is the line that I have in purple, how would I write this in interval notation? Let's say I'm just looking at the number line. I would have to look at this value here at -3, right? Is it solid? Is that solid? Oh, Carlton, you have a question? I didn't see your hand.
Yeah, I was wondering why you have a bracket and the parentheses on the,
Where? On the previous example?
yeah,
Good question. Is this circle here solid or open?
solid.
Solid. And what does it say on the definition here? When there is an equal sign, meaning that it's solid, what am I going to put? We're going to put a bracket, right? This is a parentheses. So because this is solid, that means I have an equal sign. Then I have to put a bracket. And this is why the 3 here has a bracket. Same thing. And then either or is fine. Either is however you want to give it to me. They both mean the same thing. I could come from -infinity to 3, or I could go to 3 to positive infinity. They're bidirectional. So this brings us to our next example. I hope I answered
Well,
that. Yes.
No,
Correct?
I was wondering why the parentheses is on the infinity though.
Good question. Do you know where infinity stops?
No,
No. Because it never stops, it has to be a parentheses. Because there is no stoppage. Like it's not stopping anywhere. What about the 3? Is there a stop here? Is it continuous or is full stop?
stop.
Yeah. And because it's a full stop and it's solid, it's a bracket. Because if it was open, even though it's a full stop, and let's say the circle was open, would it be a bracket or would it be parentheses?
Parentheses.
It would be parentheses because it's not included. It's not part of my solution. I'm not sitting on the chair. It exists. The chair exists. But am I touching the chair? Is it part of me? Am I sitting on it? No. So just think of it that way. Good question. So now here, how would I write this in interval notation, being that both points are solid?
You start with a bracket.
There you go. So I'm going to start with a bracket here, -3, comma, which is 2. Where does it stop?
+3.
+3. And that +3, is it going to have a bracket or a parentheses?
It's closed, so that's a bracket.
Right.
If it had a parenthesis, if it had an open circle, then it would be different. That +3 would have been a parentheses. You understand? This is values of x. Or x values, okay? Now that you understand this, we're going to do an inequality. Because inequalities are expressing the direction of the equation, And we're going to learn about some rules with the inequalities. So let's say we have -5, -4x is greater than -1, -2x. Now, the first step that you have to do is move your x's to the left. All right, that's the first thing. And you should remember, if you divide by a negative, the sign flips. So, I'll explain what that means in a moment. So, who's going to help me here? What is the first thing I got to move?
Well, X.
What does it say? Move your x to the
Left.
Left.
So which x is on the right that needs to go to the left?
The 2 minus 2.
So how do I move that -2 to the left if it's a -2?
Plus
You cancel it out.
Add it.
X.
I gotta add 2x because that's gonna cancel that. And then I'm gonna add 2x here. And now I'm gonna have what? -5. What is this? -2x is greater than -1. Correct? So now, what do I have to do to have the x by itself on the left? Because now there's a -5 on the left. What do I have to do?
Add 5 to both sides.
That's it. Now, I have -2x is greater than -1. I want to find x by itself, but that -2 is married to the x. What's the opposite of marriage?
Divorce.
Which is division. So I got to divide by what? Negative
2.
So this becomes x. And this is -2. But remember, what did I say here? Look over here. What did I say? If you divide by a negative, the sign flips. Did I divide by a negative? Isn't this a negative?
Yeah.
So if I divide by a negative, my sign is going to flip. You see how it flips? And now, what is a negative in the negative? Then this becomes a what?
I think you're wrong.
Oh, hold on. I made a mistake. Nobody corrected me. What is 5 minus 1? This is not -1. This is what? Positive
4.
4. Divided by a -2 is a what? What's going to be my answer here? -2. So let's do that again. I have -5, -4x is greater than -1, -2x. I have to keep my x's to the left. I add 2x. I cancel the 2x on the right. It comes to the left. Then I got to deal with the -5. So I add 5 to get rid of it. And I have to do the same thing to the right. 5 plus -1 is +4, right? On the left, I have -2x. I divided by a negative, right? Here I divided by a negative. That flips the sign, right? This flips, right? Because I divided by a negative. What is 4 divided by -2? X is less than -2. If I had to write this in a number line, how would I write it? What does this mean? We just did this. How would I write this in a number line? How would I write it? Where would I start?
-2.
I would start at the -2 right here. Would it be an open circle or would it be a solid?
Open circle.
Open circle. And then where is this going? What direction? To negative infinity. How would I write that in interval notation? It would be what? Parentheses, -2 to negative infinity. Parentheses. Or I can say negative infinity to -2. Why is the negative infinity and the -2 in parentheses? Why can't I have a bracket?
Not close.
Because,
The
right. This is open. Not solid. All right. So this is part of the inequalities. We need to learn this. Okay. So that was here. So let's go back. So we just did linear inequalities, page 183. Right? We still got to do quadratic formula, rectangle. Right? So let's do quadratic formula. We'll leave chapter 3 for last. We already did section 2.1. We already did section 2.2. Right? So we're going to move on to a quadratic formula. Now, yesterday we did a quadratic formula. You just didn't know that you did it. But we did it. Let's see. Which is the problem we did yesterday? Because I know some of you are like, you didn't do a quadratic formula. And I know I did. We do a lot. Let's see. Yeah, I'm going to use one of these. That's good. So yesterday, we were doing factoring, right? And factoring is to break apart. And we said that this is the same thing as ax squared plus bx plus c, plus bx plus c. What is the c value here?
-6.
-6 is the c value. What is the b value?
-1.
Yeah. And what is the a value?
1.
Good. So if this is the c value and this is the b value and this is the a value, we could write them out, right? A is equal to 1, B is equal to -1, C is equal to -6. Do you guys agree? You better agree because that's the truth. So now, if I need to factor this and I need two terms, then C is equal to -6. What is 6 divisible by? We did this yesterday, people. You forgot already? It's in the notes. What numbers go into 6?
1,
3, 2.
2, 3, and 6.
Good. 1, 2, 3, and 6. That's if you multiply them, you get, right? 2 times 3 is 6. 1 times 6 is 6, right? Those are the numbers I could use to get 6. What about B? What 2 numbers from that list can I use together, right? Because this is to add. This is to multiply, right? C is to multiply. What 2 numbers that I can use when I multiply them, but I'm adding them now, I can use to get -1. Right? I got to get a -1, and I have to get a -6 when I multiply the same 2 numbers. We did this yesterday.
-3 and
Negative
2.
3 and 2.
-3 and 2. Let's see. So if I have -3 plus 2 gives me -1. Good. -3 times +2 gives me -6. That's good. Good. How many x's do I have?
2.
I have 2 x's. What is the middle value? Is it positive or negative for B?
Negative.
So that means one is positive, the other one is negative. I know that the one that is negative is going to be 3 because we already did the math, and the other one is 2, right? I just factored, correct? Do you see that? We did factoring. Now, factoring is different than solving. So solving is actually finding a value for x. Did I hear, when I factored here, did I find a value for x, or did I just break down x squared minus x minus 6 and it gave me x plus 2x minus 3? Did I actually find the value for x?
No.
No, I did not find a value for x. These are factors. Okay. Now, if I am solving, right? So my factors were x plus 2, x minus 3, when I factored x squared minus x minus 6. But if I'm solving here, I'm going to take x squared minus x minus 6 is equal to 0. You see that? Now this question says, find the values of x that will make the equation equal to 0. This is solving. Now I need to find the value for x. But you already did the hard part. You did the factoring on the left, right? You see that? So let's do the same thing on the right. X squared minus x minus 6 is equal to 0. I factor. What do you think are my factors? What do you think are my factors?
X minus 2. Minus 3 and x plus 2.
That's right. But look what's happening here. There's an equal to 0, right? So since there is an equal to 0 here, I have to say now x plus 2 is equal to 0. X minus 3 is equal to 0. How do I find x?
Subtract 2 in both. sides.
right? So the values for x are -2 and +3. Whoa. Whoa. +3. How do I know that's right? Well, let's see. X squared minus x minus 6 is equal to 0. I am going to replace x with these values. I'm going to use -2. What is -2 squared? A negative and a negative is a positive. 2 times 2 is 4. A negative and a negative is a +2. -6. What is 4 and 2? 6. What's 6 minus 6? 0. Is that equal to 0? Yes. I'm happy, right? This works. Now let's do it for the other value. X squared minus x minus 6 is equal to 0. What am I going to replace x with? What's the other number?
3.
3.
+3. 3 times 3 is 9. A negative and a positive is a -3. -6 is equal to 0. A negative and another negative, when I'm adding them, I am not multiplying them, is -9. What is 9 minus 9? This is 0. Is 0 equal to 0? Yes. This works. What values for x will make this equal to 0? And the answers are -2 and +3. This is solving for the equation, for the quadratic. Now, on the exam, they're not going to give you such a beautiful, nice little problem for exam 2. They're going to give you something that is not factorable. What is something that is not factorable? That it means that you cannot break them apart. When you cannot factor, then you have to use the quadratic formula. So what is the quadratic formula? The quadratic formula is x, because we need to find a value for x, is equal to -b plus or minus the square root of b squared minus 4ac over 2a. I'm going to be nice enough and I'm going to give you this formula. I'm not obligated to give you the formula, but I know some of you are not going to remember the formula. And you'll probably make a mistake when you're trying to implement the formula. I'm going to give it to you. I'm going to be nice. But that doesn't mean that because I give you the formula, you know how to use it. So you have to practice. So we're going to use the same problem that we just did here, using the quadratic formula. I know you can factor, but since you already know the answer, it's going to be easier. And then we're going to do another problem that you cannot factor. So let's do the easy stuff first. So I have x squared minus x minus 6 is equal to 0. And they say you have to use the quadratic formula. If they tell you you have to use the quadratic formula and you factor, you don't get full points. Okay? Because they're telling you, use the quadratic formula. They want to know if you know how to use the quadratic formula. What is the value for A? What is the value for B? What is the value for C? We already did this. What is it? Besides Annette. Besides Macintosh. What's going on with the rest of you? Are you guys here? You're pretending to be here? What's going on? Who wants to help out? Gabriel, Grant, Hall, Riggins, Job. What do we got to do here? What's my A value? What's my B value? What's my C value? I'm not the one taking the test. It's you guys. This is the time to show that you care about your grade. Nobody? Not even on the chat? Okay. I'm going to keep going. Nobody wants to participate besides the people that already participate. Good luck to you on the exam. A is equal to 1. B is equal to -1. C is equal to -6. We already did this problem. Thank you, Hall. I appreciate your honesty. What are we going to do here? And where am I getting this from? I am getting it from here, correct? And how do I know that? Because the equation is ax squared plus bx plus c. All right, let's keep going. So now, if I have the value for A, if I have the value for B, and I have the value for C, what am I going to do? I am going to plug it into the equation. What equation? Negative B plus or minus the square root of B squared minus 4AC over 2A. What am I going to do here? I am going to replace all of these values. And I'm going to plug them in. What is the value for B?
-1.
-1.
I am going to put a -1 in here and in here. What is the value of A?
1.
1.
What is the value of C?
-6.
Thank you. Whoop, I forgot an A in the bottom, right? Yep, forgot an A. All right, so let's do this. A negative and a negative is a?
Positive.
Positive.
Thank you. 1, I have -1 squared, so a negative and a negative will become?
Positive.
Positive.
I have a -4 times a +1, that's a -4. But then now I have a -4 times a -6. So a negative and a negative is a?
Positive 24.
Positive 24. And what do I have in the denominator? 2 times what?
1
2
is
times
2.
1 is 2. Next, I have x is equal to +1 plus or minus the square root of 25 over 2. Next, I have x is equal to +1, positive -5, right? That's the square root of 25, correct?
Yes.
Over 2. I have 2 answers here. The first answer is x is equal to +1,
Plus
5 over 2. And then my second answer is x is equal to +1 minus 5 over 2. So I need to simplify those answers. I got x plus 1 plus 5 over 2. That's 6 over 2. And that is 3. X is equal to 3. And then my other answer is x is equal to +1 minus 5 over 2. That is going to give me x is equal to what? What is -5 plus 1?
-4.
-4 divided by 2. That's going to give me a -2.
-2.
Do I have the same answer as I did before? Remember?
Not a question.
Yes,
How do you
sir.
How do you get a positive 5 when it says positive and negative?
Good
And
question.
chose just 5.
Look right here. Look right here. Look right here. I love that question. That's a very good question. Look right here. Look right here. Whenever you have a square root, you have a positive and a negative. Because you end up with a positive negative square root of 25. When you take the square root of 25, what do you get? A 5, right? But remember, there's a positive and a negative outside. So that means you got two values for 5. You have a positive 5 and you have a negative 5. So instead of writing them vertically like I did, I expanded them horizontally. And here's the positive 5 and here is the negative 5. So you have two answers. I hope that answers your question. Now, if I factor this, I know I'm going to get what? What were the factors? -3, +2, right? And this is from factoring, right? And we did this before. Did I get the same answer that I got using the quadratic formula? The answer is yes. What about here? X plus 2 is equal to 0, -2, -2. X is equal to -2. Did I get the same answer?
Yeah.
Yes.
The answer is yes. So a lot of you might say, why would I ever want to walk to China if I'm able to take an airplane by factoring, right? Look how easy this is. This is so easy, right? I get X is equal to +3, X is -2 because I am able to factor. It's like snap, crackle, pop. Really easy. The reason why I did this and I did it the long way is because I wanted you to see the difference. Now, we are going to do a question that you cannot factor. And that's what we're going to do right now. So the question is x squared plus 3x minus 5 is equal to 0. Can I factor this? Well, I don't know. Let's see. C is equal to -5. B is equal to +3. Everyone knows how we got that, right?
Yeah.
Good. Right? So look down. That's good. So now, what are the factors for 5? It's going to be 1 and
5.
that's it. Can I use these same values to get 3? Even if
No.
even if 1 is negative or positive,
No.
there's just no way. So this automatically is telling you I have to use the quadratic formula. But no one's going to tell you to determine that. They're going to tell you use the quadratic formula from the beginning. And what is the quadratic formula? X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. I'm going to give you this on the exam on Friday. This is not on Wednesday's exam. Next. It better not be. Hold on, let me check. Now you got guessing. Hold on. I have the exam here. One second. Yeah, no, it's not on it. Good. All right, cool. All right, so what is my A value here? I just wrote it. What's my A value?
1.
So now X is equal to negative box plus or minus the square root of box squared minus 4 times a box times another box over 2 box. You don't have to do my boxes. This is me knowing from many years of experience that boxes work, because this is going to tell you and visualize for you which values are negative and need to be changed to a positive. But if you feel that the boxes are very elementary and you're above that, don't use the boxes. Do what works for you. This works for me, and I shared with you. Next, what is the value of B?
3.
3,
There you go. What is the value of A?
1.
1,
1.
What is the value of C?
Negative
-5. Good. So now, let's do this. X is equal to a negative times a positive is a
negative
-3. Plus or minus the square root of 3 squared. What is 3 squared?
9.
I have a -4 times a +1. That is a negative what? -4 times a +1 is?
-4.
-4 times -5 is?
20.
+20 over 2. So now I have X is equal to -3 plus or minus the square root of 29 over 2. I have two answers. I have -3 plus the square root of 29 over 2. And I have -3 minus the square root of 29 over 2. These are my final answers. I cannot go any further. I understand you have a calculator. If you want to go further, which I don't recommend because I'm not forcing you to do that, this is going to be -3 plus 5.39 over 2. And then the other value is -3 minus 5.39 over 2. And then this is going to give me 2.39 over 2. And then this is going to give me -8.39 over 2. This is 1.19. X is equal to 1.19. And then X here is going to be equal to 8.39 divided by 2. This is 4.2. Negative. If you want to get exact. But this is acceptable. This is good. Right here. This is good. Where is it? Where is it? Right here. This is good. If you stop here, you're good. If you go here and you make a mistake, I'm not taking points off. But make sure your process is correct. This is quadratic formula. I will give you the quadratic formula. All right, let's see what we got, where we ended up. So we just did quadratic formula. What section is this in?
2.5.
2.5, page 155. And we did 2.7, page 183. Now, let's keep going. Let's talk about a rectangle. And then after we do the rectangle, then we could go to break. Where's my example? Okay, you guys were asking about a word problem, right? Let's see. Rectangle. The rectangle is 2.3, 137. Section 2.3 page, what did I say? 137? I think I said that, right? Dun, 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 dun. I think I passed it. You've done so much math. I'm so proud of you guys. 2.3, 1.3, 137. Okay, good. All right, good. So let me present to you what a rectangle is. This is a rectangle. A rectangle has two long sides, which we call length. And it has two short sides, which we call widths. So if we do the rectangle, it has a length, a width, and a width. Who's lost there? Anybody lost? And this is
No.
called a rectangle. Now, I'm always drawing a guy. Let me draw a girl today. Ha. Cool. My drawing skills are not good, but that's as much as this is me as a girl. Okay, now I am walking the length of the rectangle. Now I'm walking the width of the rectangle. I'm walking the length of the rectangle. Now I'm walking the width of the rectangle. What did I just walk? What is this called? Starts with a P.
Perimeter.
Correct. Perimeter is you walking the fence.
What about area?
Area is different. We're going to be talking about area for the final.
Okay.
But being that you mentioned it, I'll give you an introduction to area. This is a rectangle, right? The area of a rectangle is the inside of the box. Well, in this case, the rectangle. So this young lady here, good question, is not going to be walking around the perimeter of the rectangle. She is now inside the rectangle. That is area.
Okay.
Good question. And area is equal to length times width. But that's not on exam 2. Okay? So let me move this. Hold on. All the way down there, because we're not talking about that now. Perimeter. How many lengths do I have?
2.
Length plus length. How many widths do I have?
2.
So perimeter is the addition of 2 lengths and 2 widths, which is the same thing as saying 2 times L plus 2 times W. Do you agree that we have 2 L's and we have 2 W's? Yes. So this is the formula for the perimeter of the rectangle. Does everyone understand what a rectangle looks like? What are the
Yeah.
characteristics of a rectangle?
Yes.
All right. So here we go. The length, so here's the word problem. The length of a rectangle what happened to my example? Is no. 5 less than triple the width. 5 less than triple the width. If the perimeter is 62, find the dimensions. And then they say the width is blank. The length is blank. So this is the problem they give you. The length of a rectangle is 5 less than triple the width. If the perimeter is 62, find the dimensions. The width is what? The length is what? Give me the answer. So I am here to show you how to solve this. So that way you could do this on your own. What are they asking for? Are they asking for a circle?
No, a rectangle. The length of a rectangle.
Thank you. So here's the rectangle. What did your instructor tell you about the perimeter? That's another key word. What is the formula for the perimeter? If you forgot the formula, which one is the length and which one is the width? And how many do I have?
4 sides.
And which one is the length? Is this the length?
No, it's the other way.
Over here?
It's up and down.
Good. That's what I want to hear. So this is the length, this is the length, this is the width, and this is the width.
Yes.
Thank you. If you forgot the formula for the perimeter, you could have write P, right? L plus W plus W. And then you would have had to, P is equal to 2 times L plus 2 times W. Because that is the formula for the perimeter. So now, this is the basic stuff that you need to be able to do the problem. Now we have to deal with this nonsense of 5 less than triple the width. Like, who speaks like that? But this is how it is written. And we need to understand what that means. What are they saying? The length, right? So this is L. You got to learn the verbiage. Is, this is an equal sign. So the length is equal to, what is 5 less than something? Well, 5 is here. 5 less than something, correct? 5 less than what? What is triple? Triple is what?
3.
Three
Three.
times.
3 times what?
5. Negative 5.
No, look. Triple the what?
With
With.
Triple the width. This is 5 less than triple the width. The length of a rectangle. So I got the rectangle. So what about the rectangle? Well, the rectangle has a length. And that length is, right? So let me write that over here. The length is equal to, right? The length is 5 less than what? Triple the width, right? But we don't write it like that, right? We have to write it as triple the width, 5 less than triple the width. This says 5 less, right? 5 less than what? Triple the width. So we don't write it like that. We write it like this. 5 less than triple the width. 5 less than triple the width is equal to what? 5 less than triple the width is equal to the length. The length of what? The length of the rectangle. So 5 less than triple the width of what? The length, right? 5 less than triple the width, right? Of what? The length. Length is equal to 5 less than triple the width. And that length belongs to the rectangle. So now, what is the perimeter equal to?
62.
There you go. So if I have all of these pieces and I put a 62 here for the perimeter, and the length, right? This length here,
Is 5. Negative 5.
the length is equal to 3W minus 5. That's what it says, right? This length here is equal to 3W, right? So I'm going to put this in parentheses. I'm going to put it in green so you see it. 3W minus 5. The length, right? If we read this way, the length is equal to 3 times the width, right? 5 less than 3 times the width. 5 less than triple the width. This is all equal to the length. So it's 2 times the length, but 2 times the length is, if the length is equal to 5 less than triple the width, then it's 2 times this, that value. We don't know what width is, right? We have no idea what that is, right? So that is plus 2W. I don't know what the width is. So now let's rewrite this. 62 is equal to 2 times 3W minus 5 plus 2W. Woo! What do I have to do now? 2 times 3W and 2 times negative 5. What is that? What's 2 times 3?
6 would be 6W.
6W. And I have a negative 10 plus 2W, correct?
Yes.
6W and the 2W. What happens? Do they talk the same language?
Yeah.
So you can
Yes.
combine them.
You better believe it. So this is going to be 8W minus 10 is equal to what? Is equal to 62. How do I find W? I want W by itself. What do I got to do?
add 10 to both sides.
I want to separate.
Divided by 8.
Yes, yes, yes. I love it. My width is equal to 9. Interesting. My width is equal to 9. My formula up here that I got was 62 is equal to what? What's the formula say? This is the formula, right? 2 times what? 2 times 3W minus 5 plus 2W. And if W is 9, what am I going to do? What am I going to do with the W?
It's 9.
It's 9.
Like,
Right? So I have 62. What is this? 3 and 9 is what? 27. 27 minus 5 is 22. 22 times 2 is 44.
44.
And this is 18. 44 and 18, is that 62? Yes, that works. So what is my length? Well, my length is equal to 3W minus 5. Didn't we say that earlier up here? The length, right? This is the length is equal to 5 less than 3, triple the width, right? The length is equal to 5 less than triple the width. So if that's the case, what is my length? Well, my length is equal to 3 times 9 minus 5. So that's 27 minus 5 is 22. So my L is 22. And what is my width?
9.
9. What are the dimensions of this? The width is 9. The length is 22, correct?
Yes.
So if I replace these values up here, this length is 22, this length is 22. Remember the parallel lines yesterday? If this one has a slope of 2, then this has a slope of 2, right? So if W is equal to what? 9, then W is equal to 9. And if I add all of these, right? 22 plus 22, that's 44. If I add 9 and 9, that's 18. And now if I add the 44 and the 18, that's going to give me a 62. Is the 62 the same thing as what they gave me?
Yes.
This problem is going to be on your test on Friday. All right, we're going to go to break because I keep my word, especially when I make promises. So we're going to break now. I'm going to pause this. It's 7:35, 7:55, 7:50. We'll be back and we'll continue this. Okay, so I'm resuming the recording. We are now in chapter 3. And we are doing functions. And for those of you who are keeping count and track of the topics, chapter 3 is here. Where is it? Right here. Section 3.1, page 201, and 3.2, page 227. That's 3.1 and 3.2. All right, ladies and gentlemen. So I hope you're able to participate in the following questions that I'm going to ask, because it is very important to understand the following concept. How many of you are in a relationship right now? You have a boyfriend, a girlfriend, a husband, a wife, a partner, anybody? Anybody here? You guys are all single?
I'm in a relationship.
Me too.
Cool. All right, very good. Thank you so much. Now, for those of you who are in a relationship, what would you say? What would you say is something very important in a relationship?
Communication.
Communication.
Trust.
Okay, I'll take communication. What would you say? Anybody else?
Trust.
Trust. Yeah. So, in order for a relationship, right? A relationship to be functional, trust, communication. So, trust, does that mean it's okay to cheat?
No.
No, right? So, functions, mathematical functions are very similar to real functions, right? For something to function in a relationship, which is you cannot cheat with your ex, right? Because now they're with you, right? You don't want them to cheat with their ex, correct?
Yes.
Good. So now that we know that little analysis there, that comparison, we're gonna talk about points. These points let's say the S set. So the S set has points. Everybody knows what points are, right? We've been talking about points for a long time now, right? So we got 1, 2, we got 2, 3, we got 3, 4, 1, 2, 3, 4, 5, right? So all of these are points. This is like X and Y, 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 X and Y. And if I'm going to draw this, I'm going to label the points, right? So this is 1, 2. So this is 1, 2. Then the next one is 2, 3. So that's 2, 3. Then the next point is 3, 4. 3, 4. Then the next one is 4, 5. 4, 5. So everyone see the points?
Yeah.
Cool. Now, when you start not trusting somebody, you start asking questions, right? Do you guys agree?
Yeah.
It's like they tell you, oh, honey, today I can't make it home early because there's a lot of work tonight and I'll probably get home maybe around 11, 10 o'clock at night. And normally they get home around 5, 6 o'clock in the afternoon. So, just don't wait up. Everything's fine. Just, I'll be home late. So they get home late. And now the next morning or that evening, you're like, wow, they're keeping you at work until like 11 o'clock at night, 12 o'clock. Oh yeah, honey bunny, it's a lot of work, blah, 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 blah. And then you go to Instagram and here he or she is at the bar or at a restaurant with some friends and stuff like that. And you're saying to yourself, why are they lying to me, right? So now you are starting to question all of that stuff. Well, in math, we do the same thing. We start creating questions. And we're like, is this a function? Are you telling me the truth? And we do that with a vertical line test. You see? Test. You're testing whether they're truthful. So, I'm going to do a vertical line test. How many times did I touch the X value? once. I'm going to do a vertical line test on the next value, which is 2, 3. How many times did I touch the X value? Once. I'm going to do a vertical line test at 3, 4. How many times did I touch the X value? How many times?
1.
I'm going to do a vertical line test at 4, 5. How many times did I touch that X value? Once. All these X values are being touched once. Do any of these values for X repeat?
No.
No. This is a function. Okay. Same test, different points. Okay, so here we go. Oh, anybody, I stayed at work all day today. Oh, it was a lot of work. I'm so stressed out. I don't even want to talk. How many times am I hitting that X value at X is equal to 1?
Twice?
That's right. So that person was cheating with his X how many times?
Twice?
That's right. This is not a function because the value of X is being touched twice. This is a cheater, not a function. Are we understanding the concept?
Yeah.
This is safe. Now, I'm just making up the letters S and C. You can name this anything. So, the most important thing that you have to understand when it comes to a function is that the value of X is not being touched more than once. You could only touch the X value once. If you touch the X value more than once, that means you're hitting the X more than once. And you're cheating with your X because you're touching it twice. Are we good there? Yes? Maybe? Okay, cool.
Yeah.
That is very important when it comes to understanding functions. So now, up until this point, we've learned about linear functions, right? This is a linear function. How do we know it's a linear function? Well, because this is the slope. This is a y-intercept. And this here, the x and the y, this is a point, correct? The x and the y, right?
Yeah.
Mm-hmm. Now, the moment I change this y and it becomes f of x is equal to mx plus b, the f of x is the same thing as y. But now it's telling the world I am a function. Before, oh, I should have written here linear equation. Before I was a linear equation. But because now I have f of x, I am a function. And what does that mean? It's like when people get married, right? They're telling the world, I am married. I am loyal. I am faithful. I am a function. Now, that doesn't mean that before you weren't faithful, but now you're telling the world that you are because you're married, supposedly, right? So the same thing with math. Before, I was a linear equation. I could do a lot of things. But now that I'm a function, I have to adhere to the rules, to the definition of a function, which is I don't cheat with my x values. Right? If I do a vertical line test, I am truthful. So now let's explain the f of x. So we had y is equal to mx plus b, and that became fx is equal to mx plus b. Let's explain the f of x. So let's break it down. So we have f parentheses and we have an x. Does everyone understand this concept? The f of x is broken up. Do you understand that? And we put it together. So if I have this, this is equal to y, and this is my x value. This is a y value. But when we put it together, my x value becomes an input. And my y value is an output. So I'll give you an example. F1 is equal to 2x plus 3. So here we are saying f is y and x is equal to 1. So where you find an x value, replace it with what? What am I going to replace it with? With 1, right? So 2 parentheses plus 3. What am I going to put in the parentheses?
The 1.
The 1. So now, if I solve this, 2 times 1 is 2 plus 3 is 5. So the f is y. So then y is my 5, right? And 5 is my output. What does that mean? When I have an input, which is x, and that value is 1, my output is y, and my answer is 5. These two values will create a point, x and y. And what that means is that this point is part of this line. What line? Well, the line is y is equal to 2x plus 3. What does that mean, 2x plus 3? Well, what does the 3 represent? We talked about this yesterday. What does the 3 represent? The 3 represents B. What does the B represent? The y-intercept. What is the y-intercept? The y-intercept is a value that has x equals to 0. So x is equal to 0. What is my y? Well, my y is B. So that's going to be 3.
3.
So this is 0, 3 is my y-intercept, correct? So what is my slope?
2.
2. What does that mean? Rise over run. So when I graph this, I'm going to start at 0, 3. And I am going to have a slope of 2, which is rise 2, run 1. And now I have a line. And this is a positive line. But I also have a point. What point is this? 1, 5. 1, 2, 3, 4, 5. This is 1, 5. Isn't this 1, 5? Yep. And this is 0, 3. So I have 2 points. This is my linear function for 2x plus 3. Now, I found my y-intercept. How do I find my x-intercept? We went over this yesterday. In order to find my x-intercept, my y has to be equal to what? 0. It's the opposite. So I have f of x is equal to 2x plus 3. The f of x is going to become y. This is 2x plus 3. What am I going to replace y with?
0.
So now I have to subtract 3 on both sides. I got negative 3 is equal to 2x. And I divide this by 2. And x is equal to negative 3 over 2. What is 3 divided by 2? Isn't that $1.50? So x is negative 150 when my y value is 0. So my x-intercept is negative 1.50 comma 0. And if I go to my graph, this value here is, let me zoom in, negative 1.5 comma 0. And this value is my x-intercept. On Friday's exam, you are responsible to do all of this. I did this yesterday. All of this. And you need to now understand that this is a function. And what a function means is now that you have the definition that you are faithful, that you don't cheat with your x, that your x values are singular and you are not hitting them twice. Now, we discussed a linear equation, which is a linear function, and they mean the same thing. The only difference is this is y is equal to mx plus b, and this is f of x is equal to mx plus b. What is the degree here? What is the degree here in that box? What degree do you think is there? Invisible. Take a wild guess.
1.
1. This is a degree of 1. What happens if I have y is equal to x squared? What is the degree here? What is the degree?
2.
2. This is now called a quadratic. We've done quadratics, right? We factored our quadratic. We used the quadratic formula. We found x-intercepts. We found the values of x. We solved for x. We factored. We used quadratics. When it comes to the function, right? Look what I'm doing. I'm turning the y into an f of x. This quadratic is called a parabola. A parabola. So now we are learning the names of these functions, right? So let's talk about these functions. How many of you like to go to the zoo? Nobody likes to go to the zoo here?
I hate the zoo.
You hate the zoo? Oh, what about the aquarium?
That's calm.
That's calm. You cool with the aquarium?
Yeah.
All right. All right, that's cool. I like that. Now, for the example I'm going to give, I have to go to the zoo because I need to know the difference between a horse, a zebra, a donkey, and a pony. You guys know what they look like, right? No? You guys remember them? No? Let's go to the zoo. I know some of you don't like the zoo. So, let's look for a horse. That's a horse. Do you guys agree that's a horse?
Yeah.
Yeah.
Yeah? Okay, cool. All right. So now let's look at a zebra. That looks like a horse to me, but they call it a zebra, right? Because it had stripes. What about a donkey? Let's look at a donkey. Ha ha, I love donkeys, right? So cute, right? What about a pony? Look at the pony. Look at the, oh, isn't that cute? Oh, look at that guy. Oh, that's a cute pony. Now, what does that have to do with functions?
Similar,
Nothing.
but not the same.
Yeah. The horse, the zebra, and the donkey and the pony, they're all animals, right? Correct? Or no? Did I make a mistake? Are they insects?
Yes, animals.
They're animals? Okay, cool. Well, think of the horse like the linear function. Think of the zebra as a parabola or a quadratic function. Think of the donkey as a cubic function. Think of the pony as the square root function. And they're all functions. But are they the same? Nope. A horse is not the same as a zebra. A zebra is not the same as a donkey or a pony, but they're all animals. The linear function, the parabola, the quadratic function, cubic function, and square root, they're all functions, but they all look very different. So right here, we're going to draw a linear function. And we're doing this because this is on your exam on Friday. This is a linear function. That's a line. This here is a quadratic function. The following here is a cubic function. The next one is the square root function. Oh, wait, there's more. Absolute value.
Did it, man? No, what you rapping? It's like
Oh, I'm sorry, I didn't hear you. What'd you say? I got the absolute of function. Then I got the cubic root function. Oh my God. How many more, Professor? Well, I don't know. Let's see. Then we got the reciprocal odd function.
see what I'm saying? Like it be hit or miss sometimes. But it's
Right.
right there. He should be coming.
Yeah,
Then
Hall.
one right here.
Oh,
One right here.
that's right,
There
Hall.
you go. Shamin.
Shamin. I don't know who that is. Quadratic function. All right, Shamin. Yeah, Shamin is in the house. Wherever Shamin is. Cubic function. I hope Shamin takes the test and passes the test. Cubic function. Square root. Absolute value. Absolute value function. Cubic root function. Odd reciprocal function. Even reciprocal function. Ladies and gentlemen, on the exam on Friday, you're going to get 3 of these. Which one? I cannot tell you, but you better know them. Because on that exam, they're going to say, just like when you play Family Feud, name that function. And they're just going to give you the graphs. And they're going to say, oh, name them. But not only are they going to tell you to name the function, they're going to want the equation of the function. So we already know the first one, right? The first one is f of x is equal to mx plus b, right? That's the linear function. What about this one? The quadratic. F of x is equal to x squared. What about the next one? F of x is equal to x to the third. What about the next one? F of x is equal to the square root of x. Have we seen the square root of x before? Have we seen square root of 25? Yes, we have. Next. The function for the absolute value. F of x is equal to the absolute value. You know what's the cool thing about the absolute value function? Everything inside the absolute value is positive. So all that negativity in the world, when it goes in there, gone. Everyone should live their life like an absolute value function. Cubic root function. I call this the freestyle swimmer, you know, freestyle. So that's f of x is equal to the cubic root. You see there's a 3 here? You see the difference between the cubic root and the square root? There's nothing here, right? But there's a number there that's invisible too. Next, I have the odd reciprocal. F of x is equal to 1 over x. What is the degree here in this box?
1.
1. And I have the even reciprocal function. What do you think is in the box? It's not going to be a 1.
2.
It's going to be a 2. Ladies and gentlemen, I present to you 8 functions. You will get 3 of them. And they're going to ask you, what are the names? And you're going to be responsible to say linear function, quadratic parabola function, cubic function, square root function, absolute value function, cubic root function, odd reciprocal function, or even reciprocal function. And not only will you have to name them, they want to know the equation. They're not going to ask you to solve it, but you better know this. This is why I keep telling you, you want to get the highest possible score on exam 1. Because as you can see, this is growing and it's getting longer and tougher. Okay? Now, let's talk about domain and range. So what is domain and range about? So this is part of what I just went over is functions right here, right? Name the function, right? Name the function and give the equation. Now we're talking domain and range. So let's talk about that. And where is this located? Section 3.2, page 227. Let's keep going. Look at all this wonderful math we've done today. So beautiful. We just learned about functions. Now let's talk about domain. The x-axis is domain. So what is domain? Domain is all x values. So what is range? Well, range is the y-axis. And what does that have to do with? Well, that is all y values. Now, what did we say about y values? Do they go left and right? Or are they the elevator? Huh? We said earlier that x values are like the train, right? They go left and right. And range is going to be like the elevator. Oops, I should pick red. Red like my blood. Red here represents range. That's up and down. Just like an elevator. Are we good so far when it comes to domain and range? You guys see it? Your silence is so confirming. So, if I look at a parabola, which is a quadratic function, which is expressed as f of x is equal to x squared. The instructor said that the x-axis is what? What's the x-axis? What's the y-axis?
Are you talking about like the vertical and horizontal line? Nah, probably not.
Yeah.
Oh, yeah.
Y is
It's-
vertical.
And X is horizontal?
Yeah. You're so spot on. You are good. I like it. I like it very much. This is good. I'm going to use the same words you use. Y is vertical. X is horizontal. Horizontal's the main. And vertical's the range. Do you guys remember what a parabola looks like? It looks like a smiley face, right? It's very happy. It's going up, correct? You guys see
Yeah.
that?
Yeah.
Good. So if I put that parabola here, what is the lowest value for y? And what is this value here?
The origin 0, 0.
Yeah, look at you. That is 0, 0. And that's an x value, and that's a y value. Since I'm talking about high and low, I'm talking about range, right? Because that's up and down, correct?
Yeah.
Good. So what is the lowest value for y?
0.
0.
Yeah, look at that. 0 is the lowest value. Is that point solid or open?
Solid.
There you go. Bracket for solid. And where are these y values going? What is these arrows telling you?
Infinito.
They're going up.
Infinito. Forget about it. It's gonna go to positive infinity. Infinito, infinity. All these y values are gonna go all the way up, like that song, all the way up to positive infinity. These are y values. I should name this red, right? Because y is red. Y values. But what about x? What's going on with the x?
Can I ask you a question?
Yeah.
So we're not meeting on Zoom tomorrow. We're just going to go straight there. Or are we going to go over some things on Zoom first before we get to the test?
We are going straight for the kill.
Okay.
I'm going straight for the exam. We are ready for war. We're going to take on those numbers and we're going to conquer them and we're going to declare victory for us to go to college. Because there is no looking back, ladies and gentlemen. Right?
Yeah. So, are we going to go over this stuff for the exam again? Can we?
Yeah.
Okay.
I'm trying to get to 9 o'clock. So we could do a little review. Because you could always play the videos back and it has everything on there. But I'm going to do a little review now. In a couple of minutes.
Okay. Thank you.
Yeah, it's good stuff. All right, so let's keep going. Domain is left and right. Those are x values. Now, how many of you ever been on an airplane?
I have.
I have.
Cool. How many of you flown to Florida?
I have.
Okay. Anybody else flown to Florida, or you guys?
I have.
Cool. Any other places you've flown? Maybe not Florida?
Jamaica.
DR.
Oh yeah, DR. Okay, DR. Cool. So now, if you've flown to Jamaica, the island, not Jamaica Queens, and DR and Florida, when you get on the plane, and now it's like taking off. Every time you cross a state in the United States of America, let's pretend you go to John F. Kennedy Airport and you get on JetBlue or Delta, American, what's the other one? Air France, any of those airlines. Is the airline pilot going to tell you, ladies and gentlemen, we are currently passing now New Jersey, North Carolina, South Carolina, Georgia. We are nearing Florida now. We are entering Florida. Do they announce every state while
No.
they're crossing?
No.
I certainly hope not, because I'm not going to fly in that airline ever again. But they do say, thank you so much for choosing our airline. We understand that you have the ability to take other airlines beside us, and we truly appreciate you flying with Delta or American or whatever flight airline. That's okay. And they do say, ladies and gentlemen, please straighten your seatbelt, straighten your chairs and fasten your seatbelts. We are now approaching our final destination. That's good. I don't mind that. But if you're announcing every state between here and Florida, man, I'm not flying on that airplane. The same thing goes with this function. What is the value of x at the origin? What is this value?
0.
0. It is included because it's solid. Now, we already spoke about up and down, right? But now we are going to talk about left and right. Because this is what? This is domain, right? Left and right, correct?
Yeah.
Look at the arrow on the left. Do not look at it from a position that it's going up. Look at the arrow on the left from a position that it's coming from the left. Do you know where it's coming from the left exactly? Or is it just going all the way to the left? All the way to the left. What do we call that? All the way to the left would be what? All the way to the left would be what?
Negative infinity.
Yes. Am I going to say that I'm going to be just like the airplane pilot? I'm going from negative infinity to negative 1 million to negative 999,999. Now I am at negative 800,000. Is it going to go like that? Or is it going to go negative infinity? Where is the arrow on the right going to go? Do you know where it stops? To the right?
No.
It's positive infinity. So it's negative infinity to positive infinity. Does that include 0 for x? Yes. It's like the airplane pilot. We're not going to mention that we're passing 0 because we're going all the way to positive infinity. Where are we coming from? Negative infinity to positive infinity. which includes 0. Just like the airplane pilot doesn't tell you all of these states going down the list. So the same thing here. So now my domain here is what? Negative infinity. Remember, domain is values of x. And where am I going? Positive infinity. Why do we write them in parentheses and not brackets? I said it earlier. Does anybody know where infinity stops?
No.
Absolutely not. We don't know where it stops. So we need to understand domain and range for this. Now, this problem is pretty interesting because it's going from negative infinity to positive infinity, and it has a floor. The floor, meaning the lowest floor on the elevator, right? What is the lowest floor on this elevator? What is the
0.
lowest? Oh, I'm sorry. I didn't hear. What'd you say?
0.
Yes. Look at this guy. I'm taking the elevator. I'm walking to the building. Dun, 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 dun. Dun, 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 dun. Right? And then I'm going to take the elevator because that's the lowest floor. Now I'm going to go up. You see it? I'm going up the elevator. And I'm going all the way to positive infinity. Or I'm coming all the way from positive infinity all the way to, what's the bottom floor? 0. Right? But now let's pretend, so that was range. But now let's pretend we're doing domain. Positive infinity. Look, I'm walking to positive infinity all the way to the right. All the way to the right. Just pretend the function continues and continues and continues, and I'm gone. Whoa. Definitely gone. Disappeared. Okay, cool. Any questions there? All right. Now, let's do another function. Let's do another function. Which function is this? This is square root of x. Now, this is my y. This is my x. Look at the blue function line. What is this value here?
0,0.
Right. That's an x and that's a y. So, who could tell me what the domain is and the range? Look at the blue line. Is it like the parabola that it's going to go all the way to the left and all the way to the right? Or it's very specific. What do you guys think? What do you think my domain is? Domain is x values. What is the first x value I have?
0.
0.
And that's going to be a bracket because it's solid. And where is this arrow going?
Infinity.
Infinito! Infinity, correct. And y values are going up, right? So this is not only going to the right, this is also going up, right? So what is the lowest y value I have here?
0.
So that's bracket 0. And where is this going to stop up? Does it stop?
Infinity.
It goes to positive infinity. That is range. Okay? Very good. Very, 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 very good. So now you guys understand the graphs. Now, how can I tell if this is a function? What kind of test can I give it? What can I test? What do we call that test? What's the lie detector test on that we give functions? What did we call it? That was the first thing we did for functions. Over here. What did we call it?
Vertical line test.
Vertical line test.
That's right. That's right. It's a vertical line test. Oh, honey bunny, I'm not going to be able to be at home tonight. I'm going to be working today. I'm sorry, can't make it on time. Maybe he is telling the truth. Maybe he is not. We're going to do a vertical line test. How many times did I touch the X value?
Once.
All of these are ones. Yes, this is a function. All right, let's do it here. How many times am I touching that X value?
Once.
Is this a function on the right?
Yes.
All right, so now I'm going to test your food skills. All right, so right now you see what? What is this? What are you seeing here?
My Little Pony.
My Little Pony. Yep. But I'm going to test your knowledge of this. What is this called?
Arepa.
Arepa. Oh my God, that's so good. Okay, for those of you who don't know what arepas are, that's an arepa. Pupusas. What are these? They're similar
Kinda
to
like
arepas.
Pupusas.
Pupusas. Oh my God, so good. Especially with cheese. All right, what are these? Cookies. Yummy. This is like the Cookie Monster. C is for cookie, and cookie is for me. Cookie, 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 right? I love it. All right. What do you guys see that it's similar to all of these? Pancakes. Oh my God, so good. What about tortillas? Tortillas. Look at the tortillas. Oh my God. So good. So what does that have to do with math? What did we all see besides food?
That they're all kind of
Circles.
Oh, you guys are so smart. Think of this as the pancake. Think of this as the tortilla, the pupusa, the arepa. So good, the cookie. Are arepas and cookies and tortillas functions?
No.
No.
No. Why not? How many times is it hitting the X? Let's say,
Twice.
yeah, this is twice. One time here, two times. You cheater, cheating with your X. No good. Twice. Bad. No good. So when you see this on an exam and they say, circle all that are not functions, is this going to be your candidate for not a function?
Yes.
Okay. Think of the tortilla and the pupusa. If you ask me, oh my God, I forgot. I'm like, do you remember the pupusa? Do you remember the arepa, the pancake? And if you forgot that, then I can't help you. Because I cannot give you answers, but I can give you hints. And if you forget the hints, then I can't help you further, right? You'll be like, yo, professor, is this a function? I'm like, do you remember the tortilla, the pancake? Oh, man. Does that mean it comes with syrup? All right, let's keep going. Oh my God, so much to do, so little time. Oh my God. The more the time passes, the more I become delusional. All right, that's cool. All right, so we got domain, we got the range. All right, so the last topic of the night before we do the review. Or you guys don't want review, right? Because you guys are good, right? You guys
Nah,
are
we need that
Good. No, we need a review.
review.
now. Everybody wants to talk. I love it. You guys are good. You guys are good. You guys are great. You know I love you guys. I got to give you tough love because if I don't give you tough love, you're not going to love yourselves. And I need you all to pass. Hopefully, 3x plus 1. So F2. And then if okay, so let's do the first one. You have this problem right here. And they're saying F2. That's how you say that. F2. What does this 2 represent? We said it earlier.
It's
This is the X value. What am I going to do with this X value? I am going to take the equation that F is the Y is equal to 3 bracket plus 1. What am I going to do with this X value?
Insert it or
Yeah.
replace. Yeah.
Good. So I got Y is equal to 6 plus 1 is what? Y is equal to 7. When my X is equal to 2, my Y is 7. So that's 2, 7, correct? Do you guys agree? This is my input.
Yes.
That's my output. This is my answer here. You see it?
Yes.
Good. So now I'm going to give you the same problem. And I'm going to say the following. If f of x is equal to 7, what is x? So what does the f of x stand for now? Is it the x or the y?
Why?
Yes. This is saying y is equal to 7. Because the x value, is there an x value in here?
No.
no.
No, there's no x value. In the previous problem, they gave you an x value, right? Look at the x value. They're saying 2. And that's why you took that 2 and you plugged it in there. And 3 times 2 is 6. 6 plus 1 is 7. So what are they saying here? Replace f of x with y. And now y is 7. What is this equation? Well, this is y is equal to 3x plus 1. What am I going to do with the y? What am I going to do with this y?
Replace it.
7 is equal to 3x plus 1 minus 1 minus 1. 6 is equal to 3x. I need to follow divorce here. X is equal to 2. I'm back where I started, right? You need to understand input and output. And I did this before, but I wanted to remind you again why the significance. All right, so let's start the review. Are you guys ready?
Yes.
All right, good. This is day 1, Friday, July 31st, chapter 1, section 1.1. This is the review for exam 1 that will be given to you on Wednesday, tomorrow, at 6 o'clock at night, and it finishes at 7:20. Try to get there early. And if you get there early, there might be another review. But if you're not there early, then you missed the review. So try to get there early. And when I mean early, no earlier than 5, you know? But between 5 and 6 is good. So, give me an example of a natural number.
1, 2, 3, 4, 5.
All right, that's good. How about a fraction?
Is it five?
number.
No, that's not a natural number. That's a rational number. Okay, somebody asked the question, will I be in the room? Okay, ladies and gentlemen, I'm glad someone asked the question. I am going to be in the room, and you will be required to bring ID. Do not send your friend. Do not send your brother, your sister, your cousin, your uncle, your mom, your dad, your boyfriend, your husband, your whoever it is to take the exam. You are going to get docked, meaning that you need to bring ID. And this is not new. You got an email. And then on that email, it says you have to bring ID. You don't bring ID, you don't take the test. You don't take the test, you get dropped. Does everyone understand that?
So if we don't have an ID, could we bring a passport?
That is an ID.
Okay.
You can bring a passport. You can bring a driver's license. It doesn't have to be from New York. I had a lady who brought me a driver's license from the United States Virgin Islands. I was like, oh, such a pretty driver's license. That's valid.
Okay.
You could bring me a passport card. You could bring me a high school card. It needs to have your picture and your name. If the picture does not look like you, that's a problem. Okay? So please, please, please bring ID. And you're going to sign. So you take the test, you sign, you get docked. When you finish the test, you bring me back the test, I check you off, and you walk out. Why? Because there has been people that take exams. Why? Because they send people to take other people's exams. This is serious business. If you cheat, you're going to be dealt with. Don't cheat. Do what you can. If you forget, call me. I'll help you as much as I can. But if you start cheating, that's the problem. If you start using your phone, that's a problem. You cannot use your phone. Oh, but I'm texting. Oh, but I'm listening to music. No. There is no music. There is no texting. If you need to text, then you text outside the room. You take your phone. You put your exam face down and you walk out, and then you text. You are not allowed to touch your phone in class. Is that clear?
Yes.
Yeah.
Please, 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 please. Now remember, are you bringing your own calculator?
Yes.
Yeah. Am I supposed to teach you how to use the calculator? No. If you don't bring a calculator, that's a problem. Because then if you need the calculator, I don't have a calculator. Am I supposed to give you pencils and erasers for the exam?
No.
No. Ladies and gentlemen, we're all adults. Behave like an adult. Show responsibility, dedication, commitment, tenacity, because you're going to need that to graduate from college. Those are characteristics of a leader, and you're all leaders. So show that you are a leader. Tough love. You understand? I want to continue with the review, but good question. What else? You're allowed to go to the bathroom. You don't have to ask me. You just take the exam face down and you walk out. And there's no time limit. If you want to take an hour in the bathroom, that's fine. But that means that you have an hour less, and now you only have 20 minutes to finish your exam. Okay? So just be mindful of that. I'm going to treat you like an adult. And as such, there are requirements that have to be met. They're very strict on this this exam. So just be mindful. Okay, natural numbers. We're good. Integers. What are the characteristics of integers?
They're positive and negative.
And they include zero.
Zero.
Yeah.
Don't forget the zero. Good. Rational numbers.
They're fractions.
Yes. Very good.
Could
are
they
fractions.
also be decimal points or no?
For rationals,
Yeah, or any of them.
I mean, they're not supposed to be.
Okay.
They're not supposed to be. They're not supposed to be. What about irrational numbers? What are two good examples of them?
Pi and square root of 2.
Ooh, look at you, you firecracker. I love it. That's so good. Very good.
Wait,
No,
would would square root of 3 also work for irrational? Right.
Good, good. What about when you have a negative inside the radical sign?
It's not a real number.
What do we call that? Nobody wants to say it.
Imaginary.
Imaginary, like Darth Vader. Very good. Very good. So, and then I gave some examples of how the questions would look like, right? Which is the following are considered a rational number? And you have to make a selection. So some of you were asking me, oh, are there going to be questions where I could select something like multiple choice and or something like that? This is as close as that as it's going to get. Everything else on this exam is now you gotta like work it. Why is that blue? Did someone scratch here? That's so weird. Hold on.
Was it you?
Was it me? I don't know. Let me clear it out. Ah, was that me? I don't know. It looked weird, right? Because it was like, never mind. Probably nobody noticed.
I have a question.
Yes, sir, Mr. Carlton.
If the fraction has a 0 underneath, is that an irrational number?
That's good. I like that. I like that. So, I like that question. Did I ask that? Was that here? Hold on. Yeah, look at that. Cool. What happens when you have a 0 in the denominator? Is that good?
No.
It's not real.
It's not real. What happens if you have a 0 in the numerator?
It's real.
Yeah, it's real.
That's 0. Good question. I like that. Good, good, good. You guys are picking it, picking it, picking it, picking it. I love it. So now, let's talk about this problem here. What happens when you have a 2 outside?
You use that afterwards to distribute it to each of your exponents or each of your terms.
Right? And we call that the product rule, right?
Yeah.
Go Power Rangers! Call Megazord. There you go. There you go. Now we will distribute that at the end. And what happens when I have a negative here?
-3.
The negative tells me something.
Reciprocal.
Reciprocal.
Yes. Don't forget that. Go back to this video and look at what we did. We grouped the numerators and the denominators based on their bases. After that, we solved each of them separately. So as you can see, we have 3 over 1 here. Then we have a to the negative third gets divided by a to the second power. And then we got b squared gets divided by b to the fourth. And then we end up in this step here. And a negative, we're adding them, right? So we got a to the negative fifth, b to the negative 2, right? Because 2 minus 4 is negative 2. And then now we can distribute using the power rule. Go Power Rangers. Call Megazord power rule. There you go. And then, am I done? No, because I get a to the negative 10 and b to the negative fourth. That means I have to get the what? What is that? When I have a negative
Reciprocal.
power, the reciprocal. And then that's why my answer is 9 in the numerator, a to the 10th in the denominator, and b to the fourth. And it becomes positive. You will see this problem on tomorrow's exam. Okay? Please review the video. 10 points.
So wait, every time you get the reciprocal, you always put it on the bottom?
Yes, and it becomes positive. So a to the negative 10 goes to the bottom. Let's keep going. Oh my God, look at this. Square roots, perfect squares. What are we going to do here with the square root of 12? We got to break it down, right? We got to break it down. But the problem that you will have on the test is going to look very similar to this. So you have to know how to break it down. You got to know how to break it down, right? 5 squared root of 12. We break it down to 5 squared root of 4, square root of 3. Square root of 4 is a perfect square. It becomes positive negative 2. We don't we don't add them, we multiply them. So that's 5 times 2 is 10. You see that right here? And then that 10 and the 2 get added, and that becomes 12 square root of 3. That's my final answer. So know how to do this problem, and you'll be good. How many questions is that so far? Next, rationalizing the denominator. I have 5 over square root of 2. I rationalize the denominator. Is this a binomial or is this a monomial in the denominator? Monomial. And because it's a monomial, I'm only rationalizing. So rationalizing means I take the same square root and I create a new fraction with the same value. Square root of 2 over square root of 2. Now I multiply across. You okay, Mazreha?
Yeah, sorry.
Nah, it's fine. If you're laughing because of the math, I love it. Keep going. So 5 square root of 2 over square root of 4. We take the square root of 4, it becomes positive 2. And 5 square root of 2 over 2. I'm done. That's another question on tomorrow's exam. Oh my God. Something fell. All right, next. What happens if we have a binomial in the denominator? What are we going to do?
You would just still write 5 radical and then you would change the sign for your 1.
Right, which is called rationalizing the denominator using the conjugate.
Conjugate.
Conjugate. Oh my God. You speaking my language. It's so cool. Very nice. And then we distribute, right? Be very careful when you're distributing because you have 2 binomials. and you got to use the FOIL method, right? First, outer, inner, last.
Mm-hmm.
And then here you cancel out and you get your final answer. So that's another question you're going to see on tomorrow's exam. Ooh.
On the, but
Can
on
you go
that,
back up?
yeah. On the question where it's like, the one with the 3 and the -1 in the denominator, when you do it on the other side, can I not just put 3 square instead of 9?
Well,
Because I've seen some people do that. That's how I was taught, at least.
if it works for you, I'm not going to say don't do it, so long as you get the right answer.
Okay.
That's the cool thing about math. There's different ways to get your answer, and it's fine. So long as
Can you
get
go
the
up a little bit more, please?
like here.
Thank you.
Yeah, no problem. Let me know when I can scroll. I'm good. Take a screenshot. You good? No? Maybe?
Yeah, thank you.
All right, cool. So polynomials. We got monomial, binomial, trinomial, and polynomial. Polynomial means you got a binomial and a trinomial. So you got to know about that stuff. And we got a new PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. And you do left to right, unless you're doing a parentheses, then you do that first. And why is that important? Because when you are adding two terms, or in this case, two trinomials or binomials, you have to see what the operation is in the middle. Doesn't matter if I have an addition sign in the middle.
No.
You're good. The problem comes where?
Subtraction. Because you have to change the signs.
When you have to do subtraction, all of these signs changes. You got -2x to the third, minus x squared, plus positive 4x, minus 3. The whole thing changed. So now I got to group them and solve, and I got my answer. So be very, very careful. You are going to see this mañana, and you'll see both an addition and a subtraction. Okay? Very importante. All right, let's keep going. All right, so then that brings us to multiplication and greatest common factor, and also division. So a problem that you're going to see is a problem like the one you're seeing in front of your screen. Do you see an equal sign next to those fractions, or do you see a subtraction sign?
Or subtraction.
Subtraction.
Does that mean I cross multiply, or I have to find a common denominator?
Common denominator.
Do not make the mistake of cross multiplying here. This is find the greatest common, well, same denominator to be exact. And then the easiest value is just to take each other's value and then multiply it and get a 12. And then here, 15 minus 8 is 7. But this is not the problem you're going to get. It's going to look like that. So I want you to
So with
understand.
those, with fractions like that, do we always use the opposite, like denominators on each side?
It helps, yes.
Okay.
Because if you get a larger value, then you're going to have to reduce at the end. Like you could have used on both sides, let's say 5. But then that's going to make everything worse because now you're going bigger and bigger. So the lowest value for each would be each other's values.
Okay, thank you.
Yeah, no problem. So then the problem that you're going to see is going to look something like that. Not like this. This is just a refresher. Like that. If you're able to do this, you're good. All right, let's just keep going. Is it going to be the same numbers? No.
No.
Do not memorize answers. I had a student once. They gave me all the answers to the problems I did. None of those are the answers to the questions. I was like, what are you doing? He's like, I just memorized the answer. I was like, no. No. Don't do that. All right. So something similar to that as well. Okay, cool. Okay, so wow. Okay, we did that. All right, so you see this problem here?
Yep.
You're going to see something very similar to that. So here, the denominator is going to get distributed with all of those monomials in the numerator. And when you simplify, you're going to get an answer like this, right? X squared plus 5x minus 3. Or here's another example. 4x to the third minus 8x squared plus 12x divided by 2x. So that's, these are real life examples from the exam, That's very important. Important. Blah, 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 blah. Can't even talk anymore. Is there a long division problem here? Let's take a look. Yeah. Yeah. You better know how to do long division. And it's not going to look like this. It's going to look like that. This one. X squared minus 8x plus 3 is the numerator, and the denominator is x minus 2. You better know how to do this problem. Very important. Long division. So, something like that. All right. So then, that was the end of Friday, and then Monday came, and I said, guys, you need to learn factoring. So, for factoring, let's see. We did a problem like this, right? For factoring, where is it? We introduced it with difference of squares. What happens when we have a difference of squares? Well, we got to break it down into 2 x's because we got 2 x's. And 9 is a perfect square, so we get 2 3s. We look at the middle value, and it's negative, so we end up with a positive and a negative 3. Then I gave another example, and I said x squared minus 4. So we got 2 x's, we got a negative value in the middle. That means one is positive, the other one's negative, and is 4 a perfect square? And the answer is yes. What are the 2 values? 2. Another difference of square. X squared minus 1. Got to know how to do that one, right? So you got to know any of these. Now, in this example, I gave you x squared minus 1x minus 6. And I said factor. And then how do you factor? Well, what is the C value? C value is negative 6. What is the B value? Negative 1. What is 6 divisible by? 1, 2, 3, and 6.
6.
What 2 values from those values that we just mentioned, 1, 2, 3, and 6, when I add them together, will give me a negative 1 and give me a negative 6.
Negative 3, 8, and 2.
That's it. And that's what we did. And that's how we got x plus 2 and x minus 3. That is factoring. And that will be on the test. Mañana.
So you have to they have to be multiplied together to give you C and added together to give you B.
Exactly. Yeah. Right. And then this is an easy one because they're both positive, right? So you're going to end up with a positive. You have 2 x's. But now you got to say what 2 numbers times itself, right? What 2 numbers when you multiply them? Give me 6. And the same 2 numbers, they have to be the same. Don't mix and match them. Like you can't say, oh, positive 2 and positive 3 will give me 6. And then positive 2 but negative 3 will give me negative 1. Some crazy answer like that. No, they have to have the same sign, same number. So in this case, they're both positive 2 and positive 3. 2 and 3 is 5, and 2 times 3 is 6, and they're both positive. Right? Then we did another example here. What is 3 divisible by? Well, 3 is divisible.
I have a question real fast. I'm sorry.
No, you're good, Carlton. Go ahead. This is a review.
The question is, do I use the quadratic formula for trinomials only? Or can I
Okay.
use it for the binomials as well?
When you say the quadratic formula, you mean the quadratic equation?
Yes.
The quadratic equation is not going to show up until exam 2.
Okay.
Good question. Okay.
Thank you.
Yeah. That x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Not here. Not here. Friday? Yes. That will be on Friday. All right. And then that brings us to the last problem on this test, which is this one. You need to know how to do this problem. What is the rule when you are dividing fractions?
I'm sorry, I had a question again. It's the a squared bx and plus c. That's from the one I was asking about.
Oh, so the ax squared. So let me go back. This is ax squared plus bx plus c, whereby c is 3, b is positive 4. This you need to use because that's how you get c is equal to 3 and b is 4.
But do you only use that for trinomials?
Yes.
So I can't use that for binomials.
No.
All right, thank you.
No. Binomials, when you are factoring a binomial, you're going to see, in this case, you're only going to see difference of squares. And that is why I'm focusing on only that. Because there are other rules as well, but I'm not going to touch on them because they're not on the test.
Thank you.
You got it. All right. So back to this bad mama jamma. What's going on here with this? What do I gotta do? Everybody's quiet now. What happened?
Can you redo this one? The one at the top, the x squared minus 9 thing.
Yeah, we can do it here. So the numerator here becomes what? Becomes x plus
And
3, x minus 3.
Yeah.
The bottom becomes x. Since I have a negative in the middle, that's positive, that's negative. And what is divisible by 6? 1, 2, 3, and 6. What two numbers from there I can use? There's going to be negative 3, positive 2, because when I add those together, I'll get a negative 1. So I just did the fraction on the left. The problem comes when I have to do the fraction on the right. I have to flip that fraction because I changed the sign. You see this? So I got to flip it because now it's multiplication. Here's division. So now the numerator, I have to do the greatest common factor. I factor it out and I get the following. X parentheses x minus 4, because when I distribute that, I'm going to get x squared minus 4x, right? So x plus 3, x minus 3, x plus 2, x minus 3. And then here, I'm going to cancel like terms. That's all I can cancel here. I have a 3 in the denominator. So now my final answer here is going to be what? Is going to be x plus 3 parentheses x minus 4. And at denominator, I'm going to have x plus 2
And 3.
times 3. I can't do anything else. That's my final answer. And that's what I should have gotten.
Wait, so how does it end up, like, how does the x parentheses x minus 4 end up on like in the same, like,
Numerator?
yeah.
Okay, no problem. So these are gone, right? In the red.
Yeah.
So this is no longer there. So I am going to multiply x plus 3 and x add all of this together, but I'm not going to distribute it. I'm just going to tie them together because they're all part of multiplication. It's like
Oh.
saying this is A, this is B, and this is C. So in the numerator, I end up with A, B, C, right? And then
Mhm.
at the bottom, I have D and I have E. So then at the bottom, I end up with D and E. I can't mix them. I mean,
Yeah, because they're not the
I
same.
can mix them, but the whole point is not to go back to where you were because you're trying to cancel things out. So you're going to end up with a final answer of x plus 3 parentheses, there's an x, and then x minus 4. Because if I start distributing everything else, then I'm going to get x cubed because there's 3 x's, right?
Mhm.
X to the third power, and then I'm going to get like this big polynomial. That defeats the purpose of simplifying.
So you always just factor first, and then you change the sign, and then you flip it. Okay.
Mhm. Yep. Very good. Very good. Good questions. Good questions. I like the questions. Yeah, so here's another example. Oh no, this is the same one, right? This is the same one. Is this the same example? No, so this is the same answer we got before, right? That's the one on the top. Here's a different example, right? Let me move this to the right. Oh my God. What do I do there? There you go. So here I have another example where I have x squared plus 4x plus 3 over x squared minus 1 is divided by 2 over x squared plus x. So you change the sign to multiplication, you flip the second fraction, you factor everything out on the numerator and the denominator, you combine like terms, and you end up with a final answer like that. Now, excuse me, what happens if you get a problem like this? This is a division sign, and I have a fraction here, and I have another fraction here. Do not get stressed. Just rewrite the problem like that. And here's the division sign, right? You see it? It's the same problem rewritten in a way that it's easily managed. So if you see it vertically, just put it horizontally. The numerator is on the left. The denominator fraction is on the right. The numerator fraction is on the left. The denominator fraction is on the right. And then you solve. You do the change flip and you got it. This was just practice that we did before. And then here, that's the end of exam 1. You see it? I wrote it here. You look at it.
Yeah.
So for tomorrow's exam, it's from here up. All of this. And we did all of this tonight. All right. I'm going to take attendance now. Pause the recording. I'm gonna stop sharing. Oh my God, it's August 4th. You know the semester starts on August 29th?
It's insanity.
I can't believe it. Like I'm teaching Tuesdays and Thursdays from 6 to 8 o'clock at night, pre-calculus. Those of you who are interested,
I
or
took pre-calc in high school.
oh, you did. Good for you.
Yeah.
That's cool. All right. So it should be on your transcript.
So
It
wait, in
is. I don't know
order,
even why.
my bad. In order to put your classes, like your schedule, we need to pass this class, right? In order to make our schedule?
Mm-hmm.
Okay. Because I was wondering, like, why can't I make my schedule yet? But that makes sense.
That makes sense. Yeah. All right, so I'm taking attendance now. Annette Benya, you're here. Alethea, not here. Macintosh Carlton, I heard.
I'm here.
Yes, sir. Janelle Riggins just spoke. Fred Fan, not here. DeAsia, where's DeAsia? Wasn't she here? Oh, I don't know. Hall, Jalen. Here. Anul. Where's Anul? Is there an Anul here?
Yes. Yes, sir.
Oh, there you are. How can I forget you? Grant, Jimon. Yes, here. Grant, are you here? Hello, Grant? Nope. Gabriel Townsend?
Yeah.
Yes. Marwa? Where's Marwa?
Here. I'm here, but I think you said my
Oh!
last.
Yeah, got you. Sorry. Job. Wasn't Job here? Yes, Job is here. Elena, I
Yeah,
saw.
I'm here.
Sofia Guzman, no la veo. Jada Clark? I thought I saw Jada. Are you serious? I thought I saw her. And yeah, that's cool. Any questions? No? So Jamon Grant, can you stay? I want to talk to you. If you don't have any questions, good night. See you tomorrow in person. 1C03. And if you have any issues or anything like that and you need to reach me, this is my phone number. Text me first. 347-460 math. You got to give me your name. Okay? All right, guys. Good night. I got to speak to Jamon Grant.
I have a question.
Hey, Hall.
So for me to be in this class, like, what is the criteria that like? I'm confused because I took all math and I never failed a math class. So it's like, you know,
Yeah, that's curious. Do you know who evaluated your transcript?
I don't remember his name. I would have to look. But he said like on my milestone, he showed me my English and writing milestone and they were there, but he said my math milestone wasn't, but I never failed a math class.
So you might want to speak to them regarding your transcripts and bring in your high school transcripts.
Okay.
Yeah. I cannot make that decision because I don't do evaluations.
No, I
But
understand that, but I thought it was for people that like failed a math class or something.
right. So you want to bring that up and show them, look, I took pre-calculus, this was my grade. And then take it from there.
Okay. Thank you.
Maybe it's the region scores
I
because
never failed the regions either.
I
I passed everything.
Yeah, that's weird. Just speak to them. I mean, bring it in, of course, you know. Like,
Okay.
Here's my transcript.
Thank you.
Yeah, no problem. Cool. All right, Jamon Grant, you got your mic on or you're just doing text? Because I got to talk to you.
Hello?
Hey, Grant, how are you?
I'm good.
All right, so you never been to campus?
I know.
So tomorrow when you come to the campus, you're going to tell them that you have an exam in 1C03. C as in Charlie 03. It's in the same level as the cafeteria, which is the bottom floor, not the basement, the lowest floor. And each of the corridors, they have letters. So you have A corridor, B, C. So when you get to the C corridor, you go in that corridor and then you're going to start looking for the rooms. 1C03. You're going to need picture ID to get into the building.
Okay. Thank you.
All right, good. Any other questions? Mazreha, Gabriel, Rafsan.
No, sir.
Good night, Anul. See you tomorrow. Gabriel, anything? No, you're
Good
good.
night, sir.
Good night. Thank you.